Okay, this is the regression review, Unit 7, and I'm going to tell you that I'm going to be focusing not so much on the questions that are asked here, but the questions that are in the Google form. So so you should follow along with the Google form as we do this. So an 11-year study of the relationship between average annual profits in millions of dollars of insurance companies and the yearly number of major natural disaster, hurricanes, tornadoes, earthquakes, etc., can be given by the following regression computer analysis output. So let's talk about this real quickly. There's talking about the relationship between average annual profits and number of natural disasters. So those are going to be my variables, but we really don't know what our X and Y is, but I can guess probably, but I'm going to take a look at what this printout has. So we have a computer printout and we'll have one on the test, and they can be different, but the one thing you should be able to find is something that says variables, or at least says the word constant. This is where we're going to focus. And by the way, if you see the word constant, that row tells me that entire row has to do with the Y-intercept. Very important to know that. And the row here that's below that will always have to deal with the slope. Now, as I said, and they can be in all sorts of different places. This could be up here or down here. They can mix things up a bit. But the one thing is I find the word constant and I go, oh, that's my Y-intercept, and directly below that will be my slope row. Now, this tells me disasters. That also tells me what my X is. So I know that X is my number of major disasters. That's X. And profits is going to be my Y. Okay, the other thing that I notice is I have an S here and an R squared, etc. So I have lots of information up here, and I'm going to probably need to be using most of it. So looking at my Google form, what was the very first thing it asked for? It asked me to identify the numerical value of the Y-intercept. Well, there's my constant, that's my Y-intercept. All I have to do is write 420.727. There we go. The next thing it asked for in the Google form was identify the numerical value of the slope. Well, technically, the numerical value of the slope is always next to the X. So my numerical value is just going to be negative 2.70909. And I can just write that down, negative 2.70909. And that's all we wanted in the Google form. Really, well, been really nice, and we're not requiring you to do this, so don't. But this is just as a reminder. It's that over 1, and this is for every one disaster. We're going to lose $2.71 million in profit. We're going to lose that amount of money for every one natural disaster. That's what's going to happen. The next thing it says is write the regression equation. So what we're going to be looking for is Y equals, really should be Y hat, but you don't have that available to you in a calculator. So you can just write Y equals 420.727 minus 2.70909x. This is my slope. It's always next to my X. Had this been a positive number, we would just put a plus sign there. Okay? But it should look something like this. Like I said, if this had been positive, we would have put a plus sign. But we have a negative slope, so we're using a negative. The next thing it asked for us was to define X in the context of the problem. So we already know X is disasters. So when we go to define it, we're going to say, let X equal the number of natural disasters. Now that partly came from the printout right here where it said X, and it also said number of major natural disasters. And really it's the yearly number, but just number of major natural disasters. is fine. And probably I should have used the word major, but it's okay that you did. Then it says define Y. Well, we already said Y. So we're going to start off with let Y equal. So what does Y equal? Average annual profits. So let Y equal annual profits in millions. Millions of dollars technically, but we'll just assume it is. The next thing it asks for is identify the numerical value of the coefficient of determination. All right, first off, you need to know that this is R squared. We're going to look on the computer printout for R squared, and it can be in all sorts of places. And that SQ stands for squared, but we see it twice. We will never use the adjusted. So my R squared value is 46.5. And you can write it just like that. So 46.5%. Make sure you use the percentile. Okay, so this is what you should have marked. Then moving on to the next part, it says, give the meaning of the coefficient of determination in the context of this problem. Okay, so they're asking for R squared in context. And so I probably need to go back and look at my notes, and I go, okay, what does it say? And here it is. So 46.5% of the variation in profits can be explained by, and I said profits because of the Y, so that's what Y was, can be explained by changes in the number of natural disasters. So 46.5% of the variation in profits can be explained by changes in the number of natural disasters. And that sort of makes sense. We would expect a insurance company to make more money if there wasn't a natural disaster, less if there were. Then the next thing it says, give the numerical value of the correlation coefficient. So I'm looking back on my computer printout, and it doesn't give me the correlation coefficient. By the way, the correlation coefficient is going to be R. It's not R squared, it's R. So what I'm going to do is I'm going to take the square root of this value. I'm going to take the square root of 46.5. But I need to turn it into a decimal first. So I'm going to make this 0.465. And then I'm just going to take the square root of it using my calculator. So here we go. 0.465 raised to the half power. That's the same thing. And I get 0.6819. So R equals, and all I had to write was this part, 0.6819. That's all they were looking for. That's all I'm looking for. Then it says, give the meaning of the correlation coefficient in the context of this problem. Now, oops, I need to back up just a moment. I forgot to check something. I need to look at my slope. My slope was negative, and because my slope was negative, my correlation coefficient is negative. If my slope had been a positive, if this had been a positive number, this would be positive. But always check that, because if it's supposed to be negative and you make it positive, it'll be wrong. If you make it positive when it's supposed to be negative, it'll be wrong. So make sure you always look at the sign of the slope and put it there. I was about to make a big mistake, jumping ahead. So the correlation coefficient, well, it's not greater than 0.75. It's between 0.4 and 0.75. So there's a moderately strong, and we said in this case it was negative, linear relationship between annual profits and natural disasters. So there is a moderately strong negative linear relation between annual profits and the number of natural disasters. Now, really what we're saying is there's a relationship between X and Y, number of natural disasters. So here's my X, annual profits is Y. So there's a moderately strong negative, because that's the direction, linear relationship between Y and X. The next thing it asked for was give the standard deviation of the residuals. Well, that's pretty easy. I don't know where it's going to show up, and it can show up at the bottom, it can also show off to the side, but look for the S. So that's the value, that's the standard deviation of the residuals. So S, in this case, was 10.17. Once again, all I need to do is write the 10.17. Please don't write S equals, just type in the number. The number 16 says, give the meaning of the standard deviation of residuals in the context of this problem. So here's what we say. The standard deviation of the residuals is 10.17 and measures the variance in profits for a given number of natural disasters. So the standard deviation of the residuals is 10.17 and measures the variance in Y, which was annual profits, in profits, for a given amount of X, which happens to be natural disaster. Okay, so that takes care of that first part. Let's continue on, and we're on to number 12. Give the numerical value for the t-statistic for the hypothesis test in this scenario. Well, that's really easy. Now, when they're asking for that, they're asking for the slope. So make sure you're looking at the slope row, not up here. And so my t-statistic is right here under the t, and it's negative 2.79. Give the p-value for the hypothesis test. Well, my p-value is 0.0209. And again, we have to stay on the slope row. We won't use the y-intercept row for that. The only thing we're ever going to use the y-intercept row for is for the y-intercept itself. So everything else is probably coming off this slope row. Okay? All right, the next thing. Given a significance level of 0.05, what is the correct decision? Well, we have a p-value of 0.029. So we have a p-value, and we have an alpha. So we have 0.0209 and 0.050. This is less than, so that means we're going to reject. So that means we can get rid of this one, and we can get rid of this one. So we're rejecting, but we need to know what the null and alternative is. Well, for slope, it's beta 1 equals 0, or the alternative, beta 1 does not equal 0. So we're rejecting this, and we believe this. So we reject the null. The slope of the line is not equal to 0. And when we say that, when we say it's not equal to 0, that means there is a linear relationship. All right, when we say it's not equal to 0, we're saying there is a linear relationship. Here we're saying there is no linear relationship. So equal to 0, no linear. Not equal to, there is a linear. We rejected this, so that means we believe this. All right, the next thing. We've now moved on to the next part. All right, we moved on to the next problem. So this will end that video. Thank you.